Very good morning, Professor Kuthe sir.
Yeah, good morning. Good morning. Can you hear me?
Yeah. You are very clearly audible, sir. Very good to see you, sir. Thank you so
Yeah,
much.
yeah. I'm also excited to see you and
Uh,
nice to see you also today. Great.
Thank you so much, sir. We are just waiting for a few minutes so that our more participant can join. Then we will start.
Sure, sure, sure. Tell me, I'm online.
Yeah,
Anytime
yeah,
you can just tell me that.
yeah.
Thank
Thanks a
you.
lot, sir. Thank you.
Okay, that's
Okay, sir. So I think sufficient participants has already joined, and time is also 11:30 this time. So with your permission, shall we start, sir?
sure, sure. I have
Yeah.
seen that 134 participants are there. That's
Yeah.
great. Very nice. Very nice. Sufficient. Yeah. Please,
Yeah,
please.
so dear participants, before our Professor Kuthi sir from VNIT Nagpur has already joined us, and before extending my request to Professor Kuthi sir to start his session, I would like to share some brief about Professor Kuthi sir and his profile briefly with you all. Dr. A.M. Kuthi sir is currently working as a professor HAG grade in the Department of Mechanical Engineering at VNIT Nagpur, Maharashtra. uh, Professor Kutesa started his career in 1986 after Bachelor of Engineering by joining HAL Nasik. He obtained his MTech from IIT Roorkee and then joined Birla Consultancy Services BIX at senior software engineer. He left BIX and joined VNIT in 1993. He earned his PhD in 2001 and his fundamental research work focused in the area of rapid prototyping using CAD as a base and specialized technique of rapid prototyping. The capabilities of rapid prototyping equipment were extensively exploited to make custom built metallic implants that were implanted in human bodies by surgeons in several complicated uh, there. He has earned 7 patents for nice work undertaken by him. His contribution to the academia and research well renowned now in present scenario. He has also published various research articles numerously in the domain of means at internationally and national journals of repute. His self motivation for introduction of industry oriented courses guiding of PhD, MTech student, as well as untiring efforts of creating awareness and building capacities for large-scale adoption of RP, rapid prototyping using CAD, is a testimony of his work in this area. So there is a lot to share about Professor Kutesar. He is a well-renowned researcher in the domain of biomedical applications using rapid prototyping, CAD modeling as well. So, sir, we welcome you, sir, and the session is just handing over to you. Session is yours, please, sir.
So
Bless
thank
us.
you, Ravi Pratap,
Yeah,
for the nice introduction, and it's really interesting to see that the NIT Kurukshetra has organized this particular FDP. It is very interesting, rather the field, as we generally call it, as an interdisciplinary field nowadays, because the and that too an aggressive interdisciplinary, because the medical and the engineering are together, and the whole credit goes to the 3D printing. And let's see how best I can convince you that this particular field is important, not only from the point of view of our academia, but also from the point of view of like how it actually helps the people in the society in general, because now we are closely associated with the medical field also. So uh, let me share my slides. I can use this share button, and contain what do you want to share, like my screen?
yeah, full screen, please share so that your PPT document,
Yeah,
whatever
because
you
they
will
are
present.
asking optimize the text and images. Click share. Okay, I
Yeah,
will just click
please.
share. Yeah, and maybe I think entire screen I can share. Yeah,
Yeah,
that's it. But then hopefully, yeah. So now I think you can see. Maybe I can just get this thing.
yes, you can. Yeah, the screen is now visible to us, so you can just directly minimize it, and your PPT can be.
Yeah, yeah, yeah. I'll take care. I'll take care. I'll
Yeah, yeah,
take care. Yeah. So, can you see my interdisciplinary research first slide?
yeah, yeah, yeah. Very
Yeah,
clear,
and
sir.
I'll just use the
Please.
now. I'll use the slideshow. Can you see that now?
Yeah, sir, it is visible.
That's great. That's great. So, if any problem is there during the delivery of this lecture, you can always call me on my mobile to
Yeah,
say that there is some problem here and there.
definitely.
Okay.
I will take care, please. Please, sir.
Yeah,
Go
sure,
ahead.
sure.
Thank
Please,
you.
please. Sir. Thank you. So, very good afternoon, rather morning now. Yet to some 20 minutes for the afternoon, but then really very nice to see you all, guys, and that too. I had just seen that how many participants are there. That's around 134. That itself shows that how the audience are interested in such type of the topic, and that's what I have mentioned. Though I have indicated to Dr. Ravi Pratap, like my topic will be 3D printing, the perfect amalgamation of the engineering and medical. So I have titled it as an interdisciplinary research, and let us see how best we can look into it as a mechanical engineering, students of the
So
faculty.
sorry to interrupt. Please, can you
Yeah,
look into the share again? I think these slides are gone, I think.
the
So
slides are
please,
gone.
yeah,
Okay.
not visible, I think, because the participants are also responding that they are unable to see in this time. So
Let
you
me
just
see.
reshare your screen again, so it will be help.
I had to reshare again. Oh, okay.
Yeah, yeah.
Share entire screen here, and then maybe here. So, can you see now?
Yeah, yeah. It is now again coming. Yeah, yeah.
Yeah.
It
So,
is
can you
visible.
see that now? Yeah.
Yeah, yeah. Please make it on full screen.
Because somebody, I think, has pressed stop sharing from there, and hopefully that might
Okay.
happen.
Yeah,
Now there is
yeah,
a,
yeah. Maybe please.
the
It is.
taskbar.
Yeah, yeah.
Uh, so
Participants, please take care of that. Don't just share by at your own, because Professor Kotesa session is going on. Don't unmute and don't share. Trying to share in between, please.
yeah, I think someone has written,
Yeah,
clicked the
definitely. I
stop
can
sharing,
understand.
and
Yeah, some
that
is.
might have happened.
Yeah,
Okay,
please,
so can
please.
you see my slide now perfectly?
Yeah, yeah, yeah. Please.
Great.
Okay.
Okay, thanks. So, happy to see that the interest of the audience in this particular so-called research, where the medical fraternity and engineering fraternity are together. So, the topic will be explained through this particular outline. So, there are 5 points which I would like to start with, like introduction, then the deployment of research. Then we are now presently working on a project called BETIC, and that's what I'm going to talk about what exactly we are doing at BETIC VNIT. Then there is another interesting project that we have already completed, and it's a smart foundry. And both these projects, like, are the interdisciplinary and at the same time multi-institutional also. So it's interesting for me to tell you that how the 3D printing is useful in that case, and what actually is our the deliverable, and finally the conclusion. So let's start with the introduction. And this is our CAD/CAM center at VNIT, where we are working. And this is the center where these particular two projects we are executing, like BETIC and Smart Foundry. The total financial outlay of these two projects is around 49 crores. And I'm really happy to tell you that it is not only the VNIT, but we are working closely with IIT Bombay and the many institutions all over the India, including the CSR labs. So we take always pride in informing the audience or our students also, like these multi-institutional and multidisciplinary projects always yield some deliverable which are useful to the society in general. Okay, so that's what exactly I'm going to tell you. So as I already mentioned to you, in our CAD/CAM center on the top, I have the two bowls that you can see, the BETIC, like we call it, the Biomedical Engineering and Technology Innovation Cell, which is an association with IIT Bombay and College of Engineering Pune. And there is a smart foundry board, like where the smart doesn't talks about the word smart in English, but it is about the sustainable metal casting by advanced research and technology. And our ultimate aim is to see that how best we can couple these two projects, and ultimately see that the deliverable is useful to the society. So 1991, everybody is aware of. That's the year where we discussed about, or rather we started the liberalization policy and allowed the industries from all over the world to enter in our India as a market. And the everybody has started taking interest in India from 1991, because they have been allowed. Earlier we used to have the monopoly trade practices, where we are not allowing anybody to enter in our domain. Then in 2019 we start about Make in India program. Like we said that, okay, now we have to think of how we will make the product in India. So it is like somewhat confusing that we are allowing others to enter into market, and then we say that, okay, I had to get the product made in India and all that. So that's fine, but then we also talked about Atmanirbhar Bharat. That means everything will be created in India and all that, which is nothing but an advanced version of the Make in India. But let me tell you that this is really very challenging, especially when you look at this particular slide. You will you will see that the challenge is not to make in India the product, but the quality of the product should match with the international standard. And that's what exactly the globalization and Make in India together we look at it. And therefore Atmanirbhar Bharat is really big challenge for all of us, because whatever the product we are going to manufacture, that should rather that should be sellable not only in India but all over the world. So naturally it should have the same quality as it is seen in international products. So here, that's what I have shown here. We are confused, like how exactly such type of the products are to be manufactured and all that. Okay. Now here, the when there is a challenge, this is what we always say. Though I am showing you here the some Sanskrita shloka, but there, what is interesting, the last line, Mahajano Yanagata Sapanta. That means you follow whatever the noble people are doing, and then you will see that most of the challenges can be tackled. And that is how the, we are following the our past president Abdul Kalam Saab, that he said that we should change our status from developing to the developed, and that's why we are always looking at when we are going to be the developed India. But then, when we say that Mahajano Yenagata Sapanta, means what are actually the people in the developed countries are doing. And this is what again a figure everybody is aware of, and everybody is even aware of what is Industry 4.0. So, Industry 4.0, then we started talking about what is 3.0, 2.0, 1.0, and nowadays even the people talk about a 5.0 also. But let me tell you that though the rest of the thing is quite clear to almost all of you, hopefully, because thanks to Google and information available on the net, that we have said that, okay, the first revolution is about the use of the steam power. Then the second revolution is about use of the electrical energy to see that the continuous production is possible through the assembly lines. Then in third revolution, we say that it is use of the electronics and IT system and more automation. And in fourth revolution, we say that it is a stable physical system. That is what we are aiming at. But if you look at the last line in this particular slide, I think that will be quite interesting. You can see my cursor here. So this degree of complexity is a major issue. Why? Because when you see the degree of complexity here, in the first revolution, there was hardly any complexity. And then ultimately in the second, there will be still more complex. Third is more complex. And fourth is really very complex. Now, when there is a degree of complexity in the any process, the only way out is to see that the academic institutes are going to help the industry. And therefore, I'm really happy to tell all of you that now, without the assistance, or without the association rather I should say, with the academic institute, in industry will find it difficult to enter into this domain of Industry 4.0. I think everybody is aware, like 1.0, 2.0 and all that. We always used to say that there has to be some academic institute interaction, and then there should be something more, and everybody used to start rather throwing the balls in everybody's court, saying that, okay, the institutes are not cooperating. We used to say that the industries are not cooperating. But here, they may not require the association that time, because the complexity was not there. But as soon as you enter into the fourth revolution, because the degree of complexity is more, there is a need of association of the college of engineering colleges or academic institutes in the institute, and therefore automatically both of them will get coupled, and hopefully we'll have to find out how best we can get this industrial revolution fourth successful. Again, I would like to put it simply one sentence here, just to if anybody asks, like, tell me what exactly the Industry 4.0 and all that. So in that case, we will only say that getting the non-defective product in one go, that's what exactly the Industry 4.0. So there will not be any wastage, the resources will be properly utilized, and ultimately we'll get the so-called quality product. And that's what exactly I already showed to you, that when we want to enter into this globalization, or rather Make in India project, Atmanirbhar Bharat project, that we do want a defect-free product and quality product. Okay, so here let me tell you about the Industry 4.0. These are the so-called various interesting field where everybody is working. And out of this field, though every all of them are interacting with each other, but additive manufacturing, to which we also call it the 3D printing or layer manufacturing or the solid free form fabrication, see, this is playing a dominant role. Or rather, I should say that it's the heart of the Industry 4.0. And that's where exactly we are focusing our attention on. So now let me quickly tell you about this. Like, manufacturing industry is now becoming a customer centric. That means there is more and more scope towards the innovation, more and more scope towards the giving comfort to the customer. And therefore, once you enter into the customer, naturally you will have to be more careful about the research that is being done as far as the manufacturing is concerned. And therefore, research and innovation is playing a dominant role. Now, how exactly we put it? We say that there is a need to focus on this high-end knowledge or the research. And let me quickly tell you about this research later on in many of my slides. But what is important here is to see that there is a need to focus towards the research, and that too, if you look at this particular line, let's say innovative and tailor made, that's what we always talk about. The product is the need of an hour. That means as you are satisfying the customer, there is a need of innovative product to be always there in the market. And every customer's need is addressed. That's what we always say. Now, interesting point is, if you look at this particular figure, which is, I'm just showing it as a big players, like all big companies like Tata, Birlas, and all that we are already aware of. Now, these companies are finding it difficult as soon as you enter into this innovative or tailor-made product, which are generally not required in masses, but maybe you have to change this design every now and then. So these big companies are finding it difficult to rather create the jobs for the engineers. Why? Because they are tuned for the mass production. And every time changing the production becomes a big issue, or rather every time changing the design is also a big issue for them. And that's why we say big no to such rather industry. But yes, the wonderful thing that nowadays talk about is the startup. That means, where if there is an innovation in the field, let us see how best the people can start their own industry. And that's what we always talked about. Now here, very interesting point I would like to show you. Like this Nandan Nilekani, everybody is aware of. I just read his interview in Economic Times during the COVID. But then he has answered very nicely the question which is asked to him, like what is the small players in India should do. So just show you here the uh, part of his interview. He has been asked, like, do you think that the future for India will be where more small players will also compete? Now, wonderfully answered by him, as I already written it in the red so-called text, that he said that it is not about the few companies that are creating millions of jobs. That's like, again, he's targeting it to the big players, the one which I already mentioned to you. But he said that millions of companies creating the few jobs, that's the solution to the our so-called more and more technical people available in the field. So if there are more startups and every startup is creating few jobs, I think the creating the new jobs are is possible, and that is how the India will definitely progress. And yes, if you look at the statistics of Economic Survey 2029 on startups, so that's the figure which is available, reliable one, and definitely I'm unable to get it on 24. But then if you look at these, there are I just tick mark it there, 4,70,000 jobs are created by more than 39,000 startups. It's something great. It is something great achievement. And that is what exactly we'll have to always look at. So more and more startups are definitely going to create more and more jobs, and more jobs creation is that ultimately is helping us in creating an ecosystem where the educated people are in the force. Okay. Now let me tell you about the what is called as the deployment of research. But ultimately, what I would like to tell you here as a takeaway message of the introduction is that innovation, thinking, research means more thrust on human resources, because ultimately who thinks, who can get the more deliverable, that will be only possible with the human resources. And therefore we have to focus or rather give more thrust on the human resources. That is what in general what we can get it from our introduction outline. So let's enter to the deployment of research, and it will be quite interesting for me to discuss about this, because I have not said research, but I said deployment of research. This is something very interesting. Let me tell you, thanks to my association with Dr. Anil Kakorkar Saab, then he said that whenever you talk about any research, you always say that how many research papers you have published, how many patents have been granted or published or filed, or maybe what is an H index and all that. He said everything is fine. That's true. We never call bad names to such things. But the interesting point is that whether the research is helping the people in the society, that is what you will have to show to a common man. Then the thing will definitely will be appreciated by the society, in the society itself. And that's why we have rather started working in this field of the our R&D project from this aspect. What is the deployment of research? That means even if the number of research papers are less, or even if the number of so-called patents are less, this okay. But if your research is rather helping the common man in the society, I think that is what exactly is more valued. So let me quickly tell you about this deployment of research. Here, I'm just showing you the Indian medical device sector, like what is the how many patents are filed, and it's a pie chart shown. But it's very disturbing. If you look at the last line, around 80% of the total patents which are filed in medical devices sectors are by the foreign applicant. And that's what I said. What you can see here, that the 80% are filed by the foreign applicant. That means now they are entering into the our Indian market with their own innovation and not allowing others to enter into that domain, and they can even tap the whole Indian market very easily. So sorry, there is a need to see that more and more patents, or more and more rather the research, should be done in this medical devices sector. Now let me tell you about the work that we have executed in this particular domain. Sorry. And in that case, I'm just showing you our work related to the metallic implants which are used in orthopedic sciences. So we call it as a metallic standard implants. And this particular figure, if you see, it shows that the joints which are used, metal joints which are used in the body, or human body. And as soon as we say it is a metal body, naturally as an engineer, we started getting interest in it. So here, what you see, if in the metallic standard implant, that there is a stiff competition with manufacture from developed country. And yes, it is true. Like look at the any joint here, especially the hip implant and the knee implants are very popular nowadays. So here, if you go and see on the net also, or you can talk to the person in the field like orthopedics surgeons, they believe more to on the joints which are available on the shelf and which are imported.
Sir,
Sorry, that means
yeah,
that.
sir, sorry to interrupt. Can you please click on the hide button which is coming over the screen so that that strip can be avoided?
Oh yeah, it's
Yeah,
okay.
yeah. Yep,
Oh, great, great, great.
it's
I
fine.
thought that it's only seen by me. Sorry, thank you. Yeah, can you see now properly?
Yes, sir.
Hello.
Yes, sir. Yes, sir.
Yeah, sure, sure. So the if you look at this hip stem or the knee joint, which are very popular, and what you'll find that most of them are available, or we get it from the developed countries, and even the orthopedic surgeons are also finding it very very confident while using that. So ultimately there is a need of rather competing with this developed country product, and that's how our Atmanirbhar Bharat we always talk about. But then, as you know, that it is difficult to enter into this domain because it has been already tapped by most of the developed countries. So then then I'm sorry, yeah, then we have started talking about why to enter into the standard implants. What happens if at all we look at the so-called customized implant? That means the implant suiting to the patient's bodies, patient's anatomy, and that is how our research started. And there you see that, as I already mentioned it in this particular slide, that there is an anatomical variation. That is what we always talk about, the personalized metallic implant, and that is where we have focused our attention. Now, I'm really happy to tell you that when we have seen a hip joint that is being used as a metal implant, then in the medical literature, the various parameters are already been listed, like a vertical offset, horizontal offset, neck angle, and all that. And it is very well defined also, like how to measure that and all that. And we then started thinking about in these standard implants how these particular parameters are considered. Say, for example, the neck angle is very well near to us because as an engineer, and then we just looked at the neck angles which are available in the standard implants, and we find that there are only 3 4 choices for the orthopedic surgeons to select out of the standard implant when the neck angle is focused. And then we started realizing, like, what is the neck shaft angle of an individual, and then how actually it varies. I'm really happy to show you here. Sorry, we have taken the 220 patients data in and around central India, I can say about the Nagpur. And then what we have seen is the neck shaft angle varies from 140 to 124. And that to the variation, you can see it is in a scattered form, not exactly that in 130 to 132, and that too in the same range, because we are talking about a central India. So ultimately, what we are realized that as neck shaft angle is varying from individual to individual, then why not to rather look at how to get a neck shaft angle shooting to the patient's anatomy and then fitting it into the patient. It's very logically correct. And if you ask the doctor why you are doing that, why you are not fitting the neck shaft angle shooting to my anatomy, naturally his answer will be, okay, then give me that, because the standard implants only talk about the only one or two or three as neck shaft angles. So ultimately, what we realized is that it is the 3D printing through which this can be possible. And how? Let me quickly tell you about our experience, or rather what we have done. Here, 3D printing is very well known. I think this self-explanatory figure explains everything, that you have a CAD file, then just convert it into the STL file, and finally, you can see that the physical model is possible on the rapid prototyping machine. So, if we put it in a simple so-called sentence, what we will say that it is the additive fabrication with minimum, or rather, even if you say without, doesn't matter, with minimum human intervention and tooling. So, if that is the case, then all traditional manufacturing is very well rather separated from this particular 3D printing. Because in traditional manufacturing, there is more and more human intervention. There is a need of tools for every operations to be done. But in case of a 3D printing, we are actually removing the tools, and human intervention is also very least. So, that's what exactly we do define the 3D printing. But what is interesting for us to look at, the computer tomography or even the MRI, what everybody is aware of, it works on almost the same principle of 3D printing, which is layer by layer manufacturing. Here in computer tomography, we talk about the slicing. That means, this particular figure, if you look at in case of the computer tomography CT scan machine, they actually take the slicing, virtual slicing of the organ, like n number of x-rays of that particular organ, to see that what exactly has happened in that particular organ. And if we can exchange the data of the from computer tomography, which is generally the DICOM file we talk about, so if we can exchange that data to the 3D printing, that means convert that DICOM file to the STL file and give it to the 3D printing machine, it should be possible for you to get the medical model, which is generally is very non-linear in feature. It's very difficult for us to get a CAD file of any organ, any natural organ. See, just imagine I ask you to get a CAD file of a heart drawn on a figure. On a computer, very difficult, very difficult, because that itself is having so many features which are non-linear, not even expressed in terms of any mathematical equation, and therefore it is difficult for us to do that. But if you can use the, say, computer tomography and 3D printing, it is possible. And the interesting point is to show me here about the implant manufacturing, a route which actually help us in getting the most of the success. Here, the CT scan data, which indicates that shared with the 3D printing machine. Then this 3D printing machine directly gives you the physical model. So you can see here, if you look at my cursor here, now this particular so-called figure is a zero point 0.5 scale of the bone which we have obtained in ABS, and that itself we have actually started using it as a pattern in terms of the manufacturing. And finally, what the here you get is a metallic model, or rather the metallic part of that particular one, which is this part whatever I'm showing it to you is the first one that we have fabricated in VNIT in 2006, and we are sure that yes, it is possible to get the metal part of the any medical organ. And it is interesting for me to show you that this is from where we have started our research. uh, this is what exactly the then we have written a R&D project which is sanctioned by the government of Maharashtra, and we have said that the development and testing of customized joint replacement using layer manufacturing, that's nothing but about 3D printing. So this particular cycle, which is very interesting for us to study, though we don't want this cycle to complete because we don't want a healthy individual, as it is seen here, to become an patient or he should meet with an accident. But when such thing happens, then the best thing would be to take a CT scan of the patient and then study that computer data it by the not only by the doctors but engineers together. And based on that data, it should be possible for us to find out what is its next shaft angle, what is the vertical offset, if at all the heat joint is to be used. I'm just talking from the hip joint point of view, but then ultimately we'll have to see that how it is useful in other areas also. So if you can get that, then you can get, as I have mentioned it here, rapid prototyping or 3D printing, the way I already mentioned to you, that you can get the pattern of it. Then we are use the casting simulation software because we want that the product should be should not have any defect. Ultimately use the manufacturing route and get that particular part which suits to the patient's anatomy, and then ultimately fit it into the patient body and see that the thing will work. So this is what we had done it from 2009 to 2014, showed the feasibility of how this can be done. And I am happy to tell you some of the interesting results that we have got it, especially in case of this particular metallic implant. We talk about the customized implant, that's what I said. And here let me tell you, which is very interesting, like there is a unmet needs, that means there is a need which has not been fulfilled from the medical point of view, and then how we have actually you identified that need and ultimately gave the solution to the doctors through this 3D printing. So let me show you here this particular case study of the what is called as the bony ankylosis. It is about the temporomandibular joint. So this temporomandibular joint is actually help us in opening the mouth or closing the mouth or even having some movement of the mouth. That's what you call it, temporomandibular. That means over the mandibular with that temper, whatever the joint that you actually look at is a temporomandibular joint through which you can open the mouth or close the mouth, whatever it is. Now this particular patient, she was a girl at the age of 6. She met with some trauma, and then ultimately her joint got fused, and that is what they call as the bony ankylosis. So there are some traditional methodology by which this can be corrected. But doctor, he said to me that he is interested in rather developing a joint, metallic joint, for which he has referred some research papers from Brazil here and there and showed me that yes, such type of the things have been already been practiced. So why not to develop a metallic implant for this particular patient? Remember here that this is where the customization is important. That means developing a joint for a patient, and though we started with the neck shaft angle and all that, but then ultimately then we started realizing that this is the interesting rather the case where we should rather develop a joint. And you will be really surprised to see these figures, like here the one which you can see my cursor, this is actually the deceased joint. And then doctor actually started telling me that how the joint is to be developed and all that. Ultimately he was giving me some idea. I was catching it up just to see from the manufacturing point of view, but I was unable to get the correct idea because the doctor is when I'm asking doctors to draw a figure of it, it was difficult. The doctors handwritings are so poor, and I'm asking them to draw some figure. I got confused, and the whole discussion were not leading to some fruitful other the result. So what I had told them, like later on, like I had given him a clay. The children lay the clay, and I just asked him, like, why don't you give me the clay model, like the whichever the complexity or rather the whatever the form you wish to create. And that's why you can see here this particular clay model. He has created clay model very nicely, And then ultimately we tried with that clay model on the so-called disease joint, where exactly it will fit, and how the thing will come into the picture and all that. So once he has created a clay model, then I had taken the reverse, through the reverse engineering, I got a so-called CAD model. And through the CAD model, then we started rather doing permutation combination. Finally, we got a very nice so-called model created in 3D printing. And then, once it is done, then rest of the thing like manufacturing and all that was become very simple. And this is what exactly the joint that we have fabricated, fitted into the patient body. And all the details, you can see it in the paper which we have published in Rapid Prototyping Journal in 2011. Please do refer that. And complete details are given there, that what exactly we have practiced and all that. And this is what exactly is one of the very interesting case which we actually see it as our success from the deployment of the research. That means somebody is getting the advantage of the research that we are doing, especially fitting the particular this implant into the patient body. And that is because of the customization. It was interesting for us to get the approval from ethical committee, from the medical fraternity and all that. So this was our success. The another one is like metatarsophalangeal joint implant that we have developed, and we have fitted into the patient body. You can see here that this is actually the 3D printed model. Then we have developed the metallic implant, and even we have tested it with the softwares, like whether how much stress it will be, because ultimately all the things which are generally used in case of an orthopedic science, naturally it will lead to more and more stress. So whether the your product is can afford the stress to which it will be developed, all this thing will very well contained. We are fitted into the patient body. As you can see here, we have taken even the feedback for the next 2 years also of the patient, and we found that this is really working very nicely. So here, this is again published in the Rapid Prototyping Journal in volume 20, number 4, 2014. Please do go through that, and you will get a complete details that how we have developed it using the X-rays, and then even there we have not taken the CT scan, but then ultimately how we have developed it and all that. It will be really interesting. Now the another one is about the use of this mandible, where it is subjected to the cancer, and then how the malignant tumor we have handled it, because that is what exactly you will always see in case of a head and neck cancer, that the very first option in head and neck cancer is to resect the part. And that's how here you can see the tumor malignancy that needs to be resected. That is what you can see here. So we have fitted one implant into the patient body and ultimately avoided the defacing of that. This is again written in Journal of Maxillofacial Surgery, volume 21, 2013. I'm really happy to tell you that all this thing has given us a very, the satisfaction to the level that we are actually helping the society. And, when we actually have done so much of work, I am really happy to inform you that recently I have been elected as a fellow of the Society for Biomaterials and Artificial Organs. So, Professor Ashok Kumar of IIT Kanpur is felicitating me on this 12th December. I don't know whether I should make it in public or not, but in general, I just asked him during the interaction, like. Generally the fellows are being given to the professors or the people from ISCs and IITs and all that. How you have selected me? So he said that it is our work in the temporomandibular joint and the metatarsophalangeal joint which has actually impressed them, and that is what they have written also in my rather the fellowship paper. Like you can see here that my contribution in a specific metallic implant using RP assisted layer manufacturing for temporomandibular and reconstruction and metatarsophalangeal joints. So what I would like to tell you here is that this actually help us a lot. Whatever the work we do for the point of view of serving the society, that is always paid, that is always been recognized. So in short, I can say that the deployment of research here, the takeaway message is need-based research is deployable, so better identify the need. Then only the research is possible for us to do. Just for the sake of doing some research here and there, I'm doing it, makes no sense. You will have to first find out where is the need. What is the need people in the society, where exactly is the problem. I think if you can identify that, I think research is possible. Okay, so now let me now quickly take you to the third, a very interesting point is about basic VNIT. That means what exactly we are doing in CARCAM Center. So I'm going to show you here by this particular tree. I think that gives you very nice. We say that the basic VNIT is like the tree. I'm showing you here the orange tree because oranges are very famous in Nagpur. So please do come anytime and enjoy oranges here in Nagpur. So here, what we say that we attract the students or the innovators in our Betik VNIT. They are all our so-called birds. And once they come, then the flower will blossom. That's what we saw about the startups. We want them to educate them. We want to guide them. We want to mentor them so that they can start the company. That is what is the startup, like a flowers. And once the flowers are there, then that will lead to fruit, that is an innovative medical devices which can be used by the people in the society to make the paper happy society. That's what we talk about Atmanirbhar Bharat. And all this is possible because of the sun, which is Betik IIT Bombay with us. So I'm really happy to inform you that this is what the structure of Betik VNIT. But let me quickly tell you what exactly we are doing at Betik VNIT. We follow the theme. We call it as engineer your research for startup. Engineer is not used here as a noun, but we use it as a verb. That means we say that whatever the research you do, you mold it in a such a way that it should be possible for you to start your company based on that. So here this figure is very easy to digest. Like here we say that okay, you have filed the patent, you have published the patent, or the patent is awarded. If you call that as a research, if you say that you have done your PhD, then if you call that as a research, or whatever the things you call it as a research, well, then everything should lead to a startup. And that's what exactly we say, that research should always end in the startup. So let me tell you a very nice thing here, that the PhDs generally are the is actually the research that we do. We even the university system also qualify it as a research work. So if that is the case, then why not to start company based on the research that we have done? And this is very interesting. Let me tell you that more the PhDs coming out of the institute are is a good indicators, and more in PhDs, then related to that there are more startup. That should be a correct equation. Otherwise, more and more PhDs are coming out and that all PhDs are hunting the job. I think that's not a correct picture. The thing is that more PhDs are starting their own company. They've got the research is done and the research is to be deployed. Then the product is innovative product is in the market, or the innovative process is in the market because of this particular research. I think that is what exactly the new India we do want in India. That's what I already mentioned to you when we have discussed the slide on the Nandan Nilekini. So here the we have actually conducted long back the symposium, and we have invited many people there to show tell them like what is their experience about starting the this startup based on their PhD. This is already available on YouTube. You can very easily see that. Almost for 5 days we have conducted this particular symposium, and it was a very interesting to see that what are the things that we should look at and all that. What is important for me to tell you here is that these are my three researchers who has actually started the company based on their PhDs. And that's what, it's very interesting for me to tell you that Dr. Sandeep Dhake, Neha, and Pranav, these people have completed some research, and their output or the spin-off of their research is a company. So I'm happy to tell you that Dr. Sandeep has actually done the work on the surgical guides in his PhD work, and his spin-off is nothing but the startup because he won the Bharat Gan. Same is the case with the Pranav and Neha. Neha has done with the Mahesh PhD spin-off, and she has developed a device for the glaucoma detection. Then the Pranav has done it on the tissue engineering, and he is now presently running a company, Lucid Implants, which is very, very famous, and they are now creating a scaffold of the various shapes and all that, and all is actually the spin-off of his PhD work. Let me tell you interesting thing here, that this Precisurge and Lucid Implants, these are very well doing the work. You can go through these their website, and you can see here in the Precisurge, this is actually the very nice instrument which the Sandeep has designed, and is also shown the feasibility. He has won not only the BIRAC grant, but then later on many grants from the government of India to the tune of crores, doing wonderfully well, though they are having some teething problems here and there. But actually they have created an ecosystem in our institute, where we always say to the students, look at them, they are the rather the people, those who have shown you a very different path, where we always say that don't become a job seeker, but it's not correct. We'll always say that the job seekers will be always there, but job creators job creators should be based on the research whatever they are doing. Now let me tell you here quickly what is our experience related to this. You know that most of the grants which are available for the startup, especially in case of medical field, it is the BIRAC grant. The number of applicants are very large, so they comes in 1,000, 10,000, 20,000 and all that, and number of grantees, or rather the grants available, is limited. So naturally it becomes rather difficult to win one that particular, or that just to get that particular grant. Now let me tell you here an interesting thing, because this is what I have experienced. Dr. Mahesh, what I have seen, that the jury always looked at them, that okay, these are the people who have actually carried out the research on this particular topic for the last 4 or 5 years, because that was their PhD topic. They have published in the various research journals also their work. That's how they got the good PhD also. So naturally, rejecting such people becomes a very difficult for the juries, because they say that they have a strong background sorry, of the research being done. And therefore, interesting point for me to tell you here is that if you can look at the deployable research, naturally you can start your own company, and that is what is the need of an hour. Okay, so in general, what I'll say as a deal takeaway message, sorry, that the focus on multi-institutional and multidisciplinary research, then you will find that it will be definitely deployable. And that's what we are trying in Betting VNIT. So let me quickly take you to the another interesting project like Smart Foundry. That is what we have finished in our VNIT. So here you can see that this I have mentioned to you that the smart world doesn't talks about the English world, but it is about the sustainable metal casting by advanced research and technology. So there, the in Smart Foundry, what actually is the our focus, because ultimately we do want that Smart Foundry and Betics should go together. Here, when you look at the medical devices, then there are various classes under which they have been classified, like class A, class B, class C, class D. At international level, they call it as a class 1, class 2, and class 3. It is very simple, because we say that it is a high risk device or the low risk device. That means the device which goes inside the patient body is a high risk device, and if at all it is used just to check the certain parameters, then we call it as a low risk device. For example, thermometer is a very good example of a class A. So you just use it to check whether you are having a fever or not. But implant or the pacemaker or any stent that you put it into the patient body, it's a high risk device. And what we need to do is that we have to focus more towards the class D devices. It's because when you actually enter into this particular class D devices or class 3 devices, now who is important is surgeon is important. Why? Because when implant is to be fitted into the patient body, and suppose the implant is manufactured in India or implant is manufactured in developed country, so naturally where the surgeon has the full confidence. That makes the difference, because ultimately patient is not going to rather give any opinion. But then if the surgeon says that, oh, I need this particular implant because I know that this is successful. So one of my very good friend and very close friend, orthopedic surgeon Dr. Manish Agrawal from IIT Bombay, when he visited our CAD/CAM center, he said that, in my wish list, I wish to see the day when the orthopedic surgeons will say that I want only the implants made in India. So that's what is this wish in his wish list, and I got impressed when he said like that. He said that, okay, the orthopedic surgeon should say that no imported implant, I want Indian implants only. So ultimately, that is what exactly is the should be the focus. So now let's see here. I'm just showing you the two implants. One is the manufactured by the Striker company. Another one is maybe a company by Sharma. And then here, if you ask that which one is to be used, the doctor will even get confused, like whether this should be used or that should be used. Okay, now here we have rather addressed this issue from a very different angle. Like when you actually look at the orthopedic implants, I think the same figure which I have shown you earlier in the earlier slides, that the our Make in India challenge of Atmanirbhar Bharat challenge, like getting a quality product which matches on the international level, that plays the dominant role here in orthopedic implants, because now the implant made in India is available, implants made by the foreign countries are available. So how best it is compare? So there are certain parameters that we'll have to look at. The first one is that it should be defect free. There should not be any defect. There should not be any defect in the part. That's what number one. Number two, that the doctor should have the full confidence in your product. So if you meet these two, the thing will be possible that we can say that yes, with that particular challenge which is being shown there, we can very really handle. And that's what exactly we are now focusing our attention through the Smart Foundry. So as you can see here, this is a logo of our Smart Foundry. What I wanted to tell you here is that we are trying our best to manufacture these particular implants through this Smart Foundry project. Uh, Quickly, I would like to show you here that what exactly we are doing in this particular project. We are using the 3D printing to get a patterns. We are using the casting simulation softwares to see that the casting will be defect free. Then we are having a melting and gravity casting, fetting and finishing, automatic molding machines and all that. But everything we want to get it displayed on the screen. That is what we call as a process display unit, and that's how exactly is our ultimate goal. But let me tell you interesting point here, that we can express the whole work through this particular chart. Though this chart is bit problematic for you to understand it in one go, but I think the last line which has been indicated is very interesting. What we have mentioned it there, that adding intelligence to manufacturing using cloud and big data and analytics is the ultimate goal. So here we are trying our best to develop a database so that the parameters to be set on the shop floor should be such that if at all the parameters needs to be changed based on the casting simulation software, then it should be automatically possible for us to take care so that the product will be always defect free. Just to give the quick example here, we always say that suppose you are using a casting simulation software, and with the ambient temperature of say 25, 28, whatever it is, you have set up the whole process parameter, that what should be the pouring temperature, what should be the flow rate of the molten metal and everything. But if at all of a sudden the ambient temperature changes during the trial or during the actual production, then what will happen? Then it will become rather difficult for you to do that. So that's what exactly we are going to create a complete decision support system or decision making system, which we generally call it that using artificial intelligence and machine learning. That if the ambient temperature changes, what should be the flow rate, what should be the so-called pouring temperature, so that the product will be again defect free. That's what exactly the last line talks about. So I'm happy to show you some of the salient features of the Smart Foundry. It will be quite interesting for me to show you here once you come in VNIT and see what exactly we are doing. But some of the salient features are that we are using 3D printer in that. Then we are using the simulation softwares. Then we are already doing the automation in more preparation and melting and pouring, the data analytics as already mentioned to you, and finally 25 by 25 by 25. Now you will be surprised to know that what is this 25 cube. Okay, so let me quickly tell you about that very nicely. Here the 3D use of 3D printer, as I already mentioned to you, that we can get the pattern very nicely fabricated as it's like a pattern maker. Then the how we use 3D printer in such type of the cases of the implant which I already mentioned to you. Then we want that the use of simulation software, because the parameters required to be maintained on the shop floor will be possible if at all it is already uh, seen on the simulation software. Then we can also give in one go what is the cost of the product, and even the gating and rest of the processing can be very easily done using the 3D printing. You can refer my paper, feasibility study of manufacturing using rapid prototyping FDM approach, where we have shown that how the defect-free product using the FDM and AutoCAD is possible. Anyhow, interesting point for me to tell you is that what is this 25 by 25? We say that it is the 25 years engineer having a area of 25 meters square and having a financial outlay of around 25 lakh should be in a position to start his own company or manufacturing unit, where he can show the feasibility of the innovative product. And that's what he will say, that he's a job creator. He will be starting his company to show the feasibility of the any innovative product. Like for example, I already mentioned to you that how the innovative products we are required in a medical domain. So if we can show the feasibility of that through the our smart foundry concept, then the venture capitalists and angels, they will get attracted, and it will be possible for him to sustain or scale that particular unit. So let me tell you an interesting thing here. If you see the text, whatever I mentioned it on the screen, like focus on design and manufacturing of innovative product. Yes, the implants, customized implant, that's what we always talk about. And the point number 2 is serving the needs of medical fraternity in semi-urban and rural sector in India. This is really very interesting. Let me take you to the second point again. Here we talk about the rural sector. There are very good doctors available in rural sector, in semi-urban area. They are having a fantastic idea how to treat the patient, but ultimately they don't have the ecosystem developed where they can actually see the feasibility of such type of an innovation or the ideation that they have started. So ultimately, if such things are possible everywhere, I hope the medical fraternity in rural sector will also get benefited, and that's how we have to serve the India. Okay. So ultimately, what is the takeaway message in the smart foundry is like focus on job creation through advanced technology and sustainability. And smart foundry is a substitute of the 3D metal printing also. No doubt, the 3D metal printing is very costly, but if you use the smart foundry concept with the FDM approach, let me non-laser based approach, I think it will serve as if it is a 3D printing. So finally, the conclusion, I think. We are on the right time for to enter into this conclusion called Bhairavi Rag, because almost 1 hour is over, and I wish to keep some time free for us, giving time for the audience to interact with me, because that's what exactly going to upgrade me also. So conclusion is simple. Like I told you, like what is this innovation research? Then I told you about the deployment of the research to the case studies. Then I have also mentioned to you like what is this startup as a PhD spin-off. That's what is being showcased. Then I told you like smart foundry is the solution to the underemployment. That means the people are getting an employment, but if it is not befitting their status in education setup, then we generally call it as an underemployment. I think the smart foundry is a wonderful solution to that. And challenge is to upgrade the researcher to do the research which is deployed. So I think it's what we have discussed. Finally, I would like to show you, before I show you my thanks word, like I'm just showing you this particular figure, or the where I'm showing you the all these traditional trains are entering into the stations, and through these stations I'm just showing that the bullet trains are coming out. So this what exactly is very nice figure. This is based on the one of the article which I have read in Economic Times. This has been written by Dheeraj Nair of Vedanta. Actually, he has written it from the point of view of the economics, and he has mentioned it like what India needs is speed. Very interestingly, he has written, as bullet train cannot run on the infrastructure built for a regular railway, he said that the high speed economy cannot run on the system designed for slower speed. And that's what exactly he focused, that okay, economy should be now take up the challenge and run fast and all that. I just modified the same sentence, and again you can read it, which I have mentioned it in a color, like as bullet train cannot run on the infrastructure built for a regular railway, now the innovative ecosystem, which is the need of an hour, cannot be created on a system designed by the Machiavelli. So Machiavellism, I think everybody is aware of the traditional teaching learning system. That is what we are going through. It is the actually Lord Machiavelli's gift to us, and that time it was fine that because the information was not available, the teacher is to teach in the class, he is to upgrade the student through that, and the classes and everything was going on. Now the system has changed. The information is available in ample. That's what we always talk about, the information explosion. So when there is an information explosion, whether the law and mechanical system is to be practiced, the answer is no. But we'll have to create an innovative ecosystem, and that is what we generally call it as the research oriented education system, where the deployment of research should be the goal, and in the same in a nutshell, the society should be should get the benefits of that. So thanks a lot for your patience hearing. I think I'm just keeping the rest of this time open for the discussion or answering the question. Okay, so I'll just
Yeah, so thank you so much, sir, for this wonderful, insightful discussion with our participants.
oh,
We are
nice,
really
nice.
very delighted to have you here and for your valuable time. So, dear participant, Professor Kutesa is now open for the queries, so you can directly interact with him, or you can just write your queries in the chat box so that we can read it for you. We are having a few minutes to conclude, so please use this time and get interact with Professor Kutesa. So, even sir will be more happy to interact with you all.
Yeah, that will be quite interesting. And I'm happy that Dr. Ravi Pratap, like the to start with, I have seen the participant was 132, and now I can see the participant was 153. So
Yeah,
I'm
even I would like to. I would be. It is my pleasure to share that our sessions are also going on YouTube Live, also, sir.
oh, nice, great,
Yeah, because of
wonderful.
the limitation of WebEx platform, so we had to go for YouTube Live.
Nice.
Yeah,
Really, very
so
interesting, very interesting.
yeah.
Sir, good afternoon, sir.
So
So
one yeah, query is like that. Take away this. So Harshal Deshmukh, he's
yeah.
asking that are you working on polymer biomaterials and their development and VNIT?
Answer is no. We are not working on polymer. We are actually working only on the metal at this moment. Because see, polymer itself is an another domain where the gold standard as of today is the metal implants, and therefore we are working more towards that. And not only from that particular aspect, but we had to work more towards the metal, because ultimately it is the the problem of what is called the stress shielding, which is a very problem as far as the implant development is concerned, because that leads to the implant loosening. So we are trying our best to solve that. And polymer, yes, itself it goes as another area where we have not entered into. Okay,
Okay, sir.
Sir, good
Thank
afternoon,
you.
sir.
yeah,
Good afternoon, sir.
yes, please
Dr.
proceed.
Dr. A. Mutturaja, sir.
Yeah,
Sir, I have one doubt, sir.
yeah.
There is any procedure we are following for collaboration with private universities, sir, to utilize this lab facility in our department?
Means you want to say the collaboration with VNIT?
Yes, sir. If you want to do some experiment, so there
Yeah.
is any provisions from our for
Yes,
outside
yes,
people, sir?
yes. It's very much possible. What you have to do is that first you have to enter into the MOU. We
Okay, sir.
So once you enter into the MOU, I think then both the institutes will be open for the discussion, and I think we can then definitely interact and then even carry our work together. Because I'm really happy to uh, answer this particular question, because ultimately what we want that this area is a high end area. We call it as a high end research. There, I hope the thing should be always pan India approach. More and more people are interacting together, getting the some deliverable as a so-called collaborative efforts. I think that will work, because high end research needs a lot of funding, lot of human resources, and that will be only possible if you all together work. So yes, it is open. You are open for that.
Sir, actually regarding
Yeah,
this,
hello,
I want to
doctor.
ask,
I
sir.
have a question. I am Dr.
Yeah, yeah,
Mantu. I have a
yes,
question.
yes,
First
yes.
of all, I thank
Sure.
you for presenting such a nice and alternate perspective about the research and
Yeah,
education and about the need of future. So I think
yeah,
some of the needs which you identified, our
yeah,
system should be reforming those things.
yeah,
Otherwise, we will be stuck up in the same old system, making no progress. And
yeah.
second thing is that now 3D printing is available at many institutes, including
Yes,
ours also.
yeah,
Uh, but the question is here that when you are printing 3D implants for the biomedical applications,
yeah.
so apart from just the feasibility, the reliability, and the safety in the patient is
Yeah.
also very, very important. So, on what parameters can I access those safety and reliability parameters?
Yeah. See, basically, when you talk about the any class 3 devices like an implant, what I'm presently we are working on, the interest important rather the thing is like getting an approval from the ethical committee of the hospital and the doctor, even the approval from the patient. All these things plays a dominant role. And when you actually enter into the customization, I think then the thing becomes rather somewhat simpler. Had it been the standard implants, then it becomes a really very tough issue. But if you can rather getting the approval from the patient or ethical committee, and if you can prove them that, like for example, one of the major hurdle that we face, like what type of a material you are using. So we say that okay, we are using the same material which has been already been used by the Indian medical field. So they immediately accept it. Okay, stainless steel 316L, done, because that's what exactly they use it. If we say that okay, we are using a titanium, this is done. So getting the approval from the ethical committee and the surgeon and finally the patient, I think that's actually plays a dominant role as far as the safety is concerned.
Thank you for the wonderful answer, sir.
Okay, thank you, sir. Thank you. Yeah.
Yeah, someone else. So one query is there written in the chat box. I'm just reading it for you. That what are the necessary 3D printing knowledge can be imparted within BTech student in regard in mechanical?
Oh, nice. I remember, like, the BTech student should be informed about this 3D printing as early as possible. Let me tell you my experience. Like, I'm also teaching the manufacturing process one to the BTech student. And, I start with the casting as a very simple process. As you know very well, it is always there in almost all the course curriculum. So, as soon as I start with the pattern making, the though rest of the things we discussed, like what are the materials available for pattern making, what are the allowances and everything, immediately I tell them like how exactly the new technology is going to help them. And there I used to tell them like, see, the 3D printing is there. With that you can even see that the pattern that you get it, we can be very easily printed without any problem, because there is less in human intervention, less tools and all that. So students all of a sudden starts looking at it, oh, what is this 3D printing? And now, with so much of the information available on the net and all that, they start rather getting more and more information. And then I used to discuss in the class, okay, if you have gone through that, let us have a discussion on this, what you have seen. I think that is how we have to always enter. So see that the 3D printing should be used as early as possible, because see, the drawing part is already over in the first year itself. So now asking them to get the CAD model, And once the CAD model is ready, how it will give you the physical model. That's how I think the 3D paintings is can be introduced to the students.
Yeah.
Uh,
Okay. Happy. Yeah. Yeah. So yeah, thank you so much, sir. What most of the queries, not
Any of
most of,
my
I think all
email
the
IDs
queries.
with you, they can see my
Yeah.
email ID on my website anytime, and they can interact anytime. It will be more interesting for me to interact.
Yeah, definitely, sir. It will be our pleasure and also the pleasure for our participants to just get interacted and also get your guidance, suggestions in between in coming time also.
Sure, sure,
So
sure.
yeah, so thank you so much, sir, for your valuable time. And I can understand that lots of projects are being there at your VNIT Nagpur, and
Yes,
it
yes,
is very
yes.
tough to get some time out of your busy schedule. So
Yeah.
thank you so much, sir, for being here and just give your precious time to us. Thank you so much, sir.
Okay. Thank
Thanks a
you,
lot.
Ravi Pratap. Thank you.
Yeah,
Should I leave the meeting now?
yeah, please, sir, please.
Okay.
You can.
Thank you. Thank you.
Okay, so dear participants, we are compiling day 5 here. As you already been informed that there is no post-lunch session anymore. So tomorrow we will meet as per the schedule. That will be the concluding day of this FDP. We also have to conduct that test as per the schedule. So you will be notified. Just keep on updating on that WhatsApp group as well. The information will be circulated. Okay. So the attendance link already being circulated for session 9, session 10. I think you all have just done mark your attendance accordingly. Yeah. So it is the compilation. Please. Thank you so much. See you tomorrow.
Thank you.